This conference will now be recorded.
Okay. Thanks, folks, for coming out to lunch. I'm at the National Center for Atmospheric Research in Boulder, Colorado, which is a big climate, weather, atmospheric science research center. And one of the things we do is run a supercomputing center. So one of the things I'm really interested in is sort of bringing modeling, things related to modeling into science education. I think there's a lot of justification of that in the next generation science standards, given that one of the practices is pretty specifically around modeling. I think one good way to do that at the K-12 level is to have students actually play around with simple models or simulations, and I want to demonstrate a few of those. That's sort of my rationale for this. I'm going to do a quick whirlwind since this is intended to be a real brief sort of session of just a few things. Most of them are ones that have been developed by our group, but I'll also show you something that's kind of a compendium of similar sort of things that I've found in other places from different groups. So without further ado, I'm just going to jump in and demo some things that I think are of interest to folks in the earth sciences. The first one I'm going to show here is called the very, very simple climate model. It's based on the notion that you've got carbon dioxide emissions, which you are in control of. You've got the resulting amount of carbon dioxide in the atmosphere, and then you've got the global temperature that arises based on that. So it's a very, very simple model, and you do projections going out into the future. So I'm just going to bump the amount of emissions up a little bit, step forward, add another dot, bump them up a little bit more, step forward, and you get the idea. We're looking at emissions, which we can control. Now I'm showing the concentration, which is slowly rising, and the temperature that is slowly rising. So the obvious thing to do is to just run emissions up for the rest of the century, and surprise, surprise, temperatures will keep rising. But another way you can do this is to have temperature or emissions rise for a little while, then say, well, we're starting to use more green energy sources, less fossil fuels, and in fact, have them start going down towards the end of the century. And because even though we're reducing emissions, we're still putting stuff into the atmosphere faster than it can be pulled out by the Earth systems. The concentration continues to rise and temperature continues to rise, although it tends to flatten off in this scenario. So this is a bit counterintuitive for a lot of people, and that's kind of the main point of this simulation. You can try all kinds of other sort of what-if scenarios of your own devising or of your students' devising under this. Moving right along, we've got a piece about learning about layers of the atmosphere. Let's see, I think I'm going to jump to the second level because it's a bit more interesting. So instead of just being shown a diagram of the different layers of the atmosphere, the idea here is that you launch balloons that can take readings of temperature and air pressure, and along the way you discover that there's certain places where there's dramatic shifts in the temperature profile, and that's the places that we call the different layers. So if I launch a first balloon, we can see that the temperature is slowly decreasing as we go up. So going from 20-ish degrees at ground level to minus 30 at, what is that, about 10 kilometers. I can launch another balloon and let's take some data a little higher up. So make a new balloon, launch it, and we've now gotten up into the stratosphere where temperatures are actually rising with altitude. And I'll just do this kind of quickly to give you the flavor. You actually get 4 data points per flight and 4 balloon flights, so you have to be a bit judicious about where you take data and so forth. So anyhow, here I've gotten a little bit higher still, and we get up to the top of the stratosphere and start to get into the mesosphere where things start to cool off again. So anyhow, that's the basic idea of that. We just recently converted this from Flash to HTML5, so it will run on tablets and other devices that are no longer supporting Flash. We haven't quite moved all of the features over. The original version is still online. And it has some data about atmospheres of different planets, Mars and Venus, and some other scenarios too. The next one I want to show is along the lines of paleoclimate, and the most familiar paleoclimate proxy is tree rings. So we've got a couple of pieces around that of how we use these different paleoclimate indicators to find out about past temperature and other conditions. So this one, you basically are given half of a tree cookie and you're trying to match it by simulating the conditions of the years of its growth. So if I grow a new ring with normal conditions, that seems to match, so I'm on track. If I grow a second ring under normal conditions, I don't know if you can see it well at the scale of your monitor and so forth, but it's a little bit off. So let me remove that one and see if maybe it was wet conditions that year. I try that, that seems to work out. I happen to know that the next year was back to normal, and the following year after that was dry conditions, and then I don't know, I think it's normal again. And you can see that you gradually, if you make the right choices, you can build up a matching half of a tree cookie to match the pattern there. And it also builds a graph up across the bottom that you can then do some interpretation around. Are there long periods of drought? Are there long periods of wet spells or so forth? This level of the game is emphasizing using moisture as the indicator. Tree rings are also responsive to temperature. So we have a level where you play around with different temperatures, and then it gets really tricky when you start combining them. So you have to get both the right level of moisture and the right sort of temperature conditions to match the tree ring, which makes it more realistic but more challenging to do. And I just realized that I meant to throw some URLs of where this stuff can be found online into the chat room. So let me do that quick before I forget. In general, our interactives are available at the URL I just threw in there, and let me put the specific ones of the ones I've shown. So this is the URL for the simple climate model, and here it is for virtual ballooning, and then here's the tree ring one. Okay, caught up with that. We have one in production, another one around tree rings that's not quite done yet. We're working with some partners in the UK around this. It's got some opening screens, but the basic gist of it is that you collect some samples from both living trees, but also from beams from ships or log cabins, and then try and build up a longer chronology. So the idea is that we've got some tree ring cores here along the bottom, and we can slide them back and forth until I find a match set. So the one that I'm moving here might be from a living tree. This one might be from a log from a recently downed tree. And then the bottom one might be from a log cabin or something that was a bit older. So if I can find a match to these patterns, which I happen to know roughly where it is, and get them lined up. Let's see, where's this one? There it is. A graph of the temperature record that corresponds to that appears. So this one's not quite done. We hope within the next couple of months to be finished with it, and we'll certainly make links to it from the other tree ring one. Let me see how I'm doing for time. I think I'm mostly pretty low on the time that I've got. Margaret, please do cut me off whenever you need to.
We'd love to see one more.
Okay, let me show you one compendium, and then I'll actually show you one more interactive. So this item, and I'll paste this in here, just for reference, I've been really interested in these kind of things for years and have collected a bunch of links to them. So this is kind of a lit review, as it were. Margaret and I were talking earlier about how there's folks at her institution, University of Wisconsin, that do some really nice simulations. There's a lot of good stuff out there, so that's what this is about, is just pointers to things along these lines that I've found. I'll throw you one last piece. This is about Earth's energy balance, the fact that you can make a real rough calculation of the temperature of a planet based on its distance from the star, or how bright the star is, and the albedo or shininess of the planet. You can find sort of calculations of this that you can do online, various places. We've got a fairly in-depth page behind it here that I'll just give you a quick glance at, that sort of shows diagrams and how you do the calculations. But the idea here is that with the interactive, you don't need to, although you can show the math behind the scene. But you basically just play around with the planet's albedo, and the brighter it is, the more sunlight gets reflected away, and the colder the temperature tends to get. If you make the surface really dark, you can get it kind of warm, but still pretty darn cold. And this is often used in introductory climate classes, this notion, as an explanation of why some amount of greenhouse effect is a good thing, because otherwise most of our planet would be below freezing. And this is an illustration of this. You can do things like pick a surface. So let's say if we want sea ice, it'll pop you to the appropriate albedo. We've got a bit of a table here describing the different sort of surfaces and the kind of range of albedo. You can play around with the sun's brightness as well and mess around with different temperature scales. And then, as I mentioned, if you want to get into the math and do that kind of stuff with more advanced students, we've got the equations that one does this by hand with, shown here. But if you play around with the sliders, it changes the numbers in the equation, so sort of makes a connection there. So I'll pause with that and hand it back over to you, Margaret.
Thanks, Randy. That's amazing. These are so great. And the fact that you're getting them all in HTML5 means they run on anyone's browser, right? All browsers.
Yeah, they seem to be working pretty well on a range of browsers. I've tried them on Chromebooks. The iPads are the stickiest ones for Flash, and they seem to be behaving on that. So not all of these are converted yet, but we're in the process, and most of the ones that I showed you today have been moved over.
Yeah, we've had to do that here too. So everyone is unmuted. If anyone has a question for Randy, go ahead. I wanted to mention, while others think of their questions, I'm definitely going to incorporate this last one into a class we have here at the UW. It's Climate and Climate Change. It's a 100 level class, and it's entirely online. And I think this last exercise would be excellent to put in there and ask a few questions and have them answer them. So thanks for showing me that.
Yeah, and I'd love to hear your any feedback you have on how that goes and so forth.
It's every summer, so that'd be next year. But yeah, I'll be back in touch. I'll remember. Does anyone have any questions?
Yeah, this is Patrick Chandler. I'm listed there as ESIP Group 3, but Randy, I'll be helping run your presentation next Tuesday to the Clean Network, so I look forward to the extended version of this one, and we'll be reaching out to you for some slides. But was wondering, are these mostly standalone tools? Have you built lessons around them, or have you reached out to folks that have lessons that would really be enhanced by these tools? So I always find, the trickiest part when you make a good tool is making sure it gets used.
Yeah, so that's a really good point. Some of them we've written up lesson plans to go with them. I think they're pretty well documented on the page that has the interactive. If there's a sort of a teacher guide activity lesson write-up with them, we usually put a link to that right up at the top. Not all of them do. That is another thing that we're, with some of them, getting ready to sort of flesh them out now that we're getting there with the HTML5 conversion. Another key point is to make sure all of them have some sort of lesson plan. Some of them have been used, embedded in other curriculum by other groups. I know Turk was doing a series a few years back where they used the simple climate model in it. I've gone back and forth with that. Some groups are very keen on, like the Concord Consortium, I know they're very keen on making sure that they wrap curriculum around any interactives they build. In fact, the interactives really are sort of the second thing they're kind of added into the curriculum. I know the FET group at University of Colorado kind of intentionally takes a bit of a different approach of sort of building the tools and then throwing them out there for teachers to sort of make lessons that fit for them. So I think there's a mix. I think the notion of intentionally at least building some sort of a lesson and then making it easy for people to use it however they want is my main approach. I'm a little behind on the building the embedded lessons part for some of these.
Great, thank you.
Anyone else? Well, if not, I have to say, Randy, that was just excellent. Excellent demonstration. I really appreciate it. Thank you, everyone, for tuning in. We have one more this fall, and on December 19th, we'll send out an invite before then. Meanwhile, thanks again. Thanks, Randy. It's great.
Thanks, Randy.
Yeah, thanks for hosting, and yeah, thanks for the opportunity.